All right, now let's look at some more problems with factoring completely. This is the second part of a video on factoring completely. This is just a couple more examples. First, let's look at the problem, factor 10x4 minus 13x squared minus 3. Now, if you notice, this is in the form ax to the fourth plus bx squared plus c, and there's a certain trick to factoring that. You basically pretend this is an x squared and this is an x. So if we pretend this is an x squared and an x, then we're going to have AC factoring. You're going to have, since this is a minus and a minus, you're going to have 1 plus and you're going to have 1 minus. And now there's two ways to do it. One way is the AC method. You go 10 times 3. 10 times a negative 3 is a minus 30. What two numbers multiply to 30 and add to 13? It looks like it's going to be 10 and 3, except for one's positive, one's negative, so that won't work. So let's try 15 and 2. That's going to work, 15 and 2, right? Now that's going to be a plus 2 and a minus 15. Now you're going to use factoring by grouping, 10x4, and it doesn't matter what order you put it in, plus 2x minus 15x minus 3, and then I'm going to group these two together and these. See what I did is I just took b, the minus 13x, and I split it into positive 2x and a minus 15x. Then I do back factoring by grouping. Here I can take 10x4, I can take a 2x out. If I take a 2x out, I have a 5x3 plus 2. And here I can take, oh, this is x squared and x squared. My bad. This is a 2x squared out. So then that's 5x squared plus 2. Here you have 15x squared minus 3. So there I can take, it looks like a minus 3 out, and that becomes 5x squared plus 1. And I made some mistake here, right? I think these two should match. It could be they don't factor by grouping, but let's check. Here I divided by 2. 10 divided by 2 is 5. Here I divided by 2. 2 divided by 2. 2 divided by 2 is 1. So if you use factor by grouping and they don't match, there's one or two possibilities that you can't factor by grouping or you made a mistake. Luckily I made a mistake. Then you have 2x squared minus 3. 5x squared plus 1. I'm going to take a 2 out here, and I get x squared minus 3. I'm going to take a 5 out here, and I get x squared, and that's going to be a plus 1/5. This is a minus. This is the difference of squares. So that's going to be 2x plus root 3, x minus root 3, times 5. This is squares, but it's the sum of squares, so I have to use an I. So that's going to be an x plus I root 1/5, x minus I root 1/5. And that's actually my answer. I just need to rewrite the answer. That's 5 times 2 is 10. X plus root 3, x minus root 3, x plus I root 1/5, x minus I root 1/5. We might notice something. On our original problem, our degree was 4, and we end up with 4 linear terms. And in our original problem, our leading term was 10, and our leading term is 10. Let's do one more problem. 6x to the fourth plus 12x3 minus 14x squared minus 28. Let's group these and group these. 6, this has a 6x cubed together, right? You can factor that out, and that becomes x plus 2. Here we can take a minus 14x out, and then you end up with an x minus 2, no, it's a minus 28 minus, so that's an x plus 2. So you get 6x to the 3 minus 14x times x plus 2. And that's just simple factoring by grouping. Factor by grouping. Now, at this stage, what you're going to do is you can factor this one. See how it has an x in both of them? I'm actually going to take a 6x out, divide this by 6x and this by 6x, and then I get x squared minus, the x's cancel, it's 14 over 6, which is 7 over 3. X plus 2. That's just monomial factoring. Here I have the difference of squares. The difference of squares, that's going to be x minus root 7 thirds, x plus root 7 thirds, x plus 2, multiplied by a 6x. That's going to be my final answer. Now we could simplify root 7 thirds if we want to. That would be fine. If you simplified root 7 thirds, you would get root 21 over 3. Whether you do that or not, for our purposes, are fine. This is our final answer. And that's some more examples of completely factoring.